Okay, we are going to now kind of put everything together. So we've talked about ratios and what it means to be proportional, that it's increasing at the same rate. Both sides are keeping the same balance. We've done some work with tables. We've done some work with graphing. And now we want to put all these pieces together. So I have, at the top of this, I have two tables. And the biggest thing for you to get in your brain, to really get solid in there, cement in that brain, is that there is a difference between a relationship being linear and a relationship being proportional. To be proportional, it has to be linear. But a linear relationship is not always proportional. So I want to look at the two tables we have here. We said that linear, and I'm looking down at the red, it says changes by a constant rate. Okay, so that I know that each time x goes up by 1, right? And so I'm going up by 1 each time, plus 1, plus 1. The x, the y goes up by the same amount every time. Plus 3, plus 3, plus 3, and plus 3. So this is linear. I'll say, to be clear, this is linear. This is a linear relationship. If I put it on a graph, it would be a line. Okay, and now I'm going to look at the one to the right. Okay, this goes up by 1. This goes up by 1. I am trying to make it as neat as possible. This goes up by 1, and this goes up by 1. This goes up by 3. This goes up by 3. This goes up by 3. And this goes up by 3. Okay, so there I'm going. I'm in both of them. As x goes up by 1, the y goes up by 3. This is also linear. However, to check to see if it's actually proportional, what you need to see is there a unit rate? So if I'm multiplying the x by the same amount every time, then I have a proportional relationship. Okay, because I know here that if I write these as proportions, 1/3 is proportional to 2/6, is proportional to 3/9, is proportional to 4/12. I know that, okay? So I can say in this, every time I take the x, I can multiply the x by 3. I can multiply the x by 3 times 3, a little sloppy there, times 3. I have proportionality. These are, right here, these are proportional ratios. Now I'm going to look at the other side. I have 1 over 5. I have 2 over 8, 3 over 11, and 4 over 14, 4 to 14. These are not proportional. And so I can look here and I can say this is times 5. This is times 4. This is times 3 1/3, maybe. This is times 3 1/2. But you can see that there is no unit rate. There's nothing that I'm doing. For every 1, it goes up 5 times. It doesn't, because this would have been the unit rate. Okay, but on the left side, that is something that is going up, not only linear, going up by the same rate, but also has the unit rate. So this is proportional. The other one is not. Okay, so again, you can be linear, but not be proportional. And there are two things for proportionality that you can look at if you're looking in a table. You'll notice that the 0, 0 will always be a data point in the table, in the graph, in the equation. When you multiply the 0 times the unit rate, the y will always be 0. So 0 times 0 is 0. So you will always go through 0, 0, and there will always be a unit rate. And they write it like this. When x is 1, the unit rate is y. Some people write it as k, but for the most part, you'll see it like that. So this right here, this number is the unit rate. So we're going to practice this more in class, but I want you to get this straight. So to be clear, I'm going to say it one more time. A relationship can be linear and not be proportional. Okay? So let's look at these practice problems down here. I'm gonna look at this. So I'm saying, first of all, is it linear? As x goes up by 1, does y go up by the same amount? Yes, y goes up by 1. So that is linear. That's linear. Okay, is it proportional? Am I multiplying the x by the same number every time? Well, this is times 3. Is 2 times 3 4? No. Is 3 times 3 5? No. So it is not proportional. Okay, so let's do the next one. As x goes up by 1, y goes up by 4. So it is linear. It is linear. Is it proportional? Well, 1 times 6 is 6. Is 2 times 6 10? Is 3 times 6 14? No. So it is not proportional. Let's go to the next one. Plus 1, plus 1, plus 1. Plus 2, plus 2, plus 2. So that is linear. Now I'm going to look for the times. I look at the x. Here I'm multiplying by 2. Here I'm multiplying by 2. Here I'm multiplying by 2. So it is also proportional. Okay, and let's notice, even in the table, I can see the 0, 0 point. So I have a unit rate of 2. So the unit rate would be, let's just be clear, those numbers would be, it goes through 0, 0, and it has a unit rate of 2. That's the unit rate, okay? So the rate is 2. The unit rate is 2. Okay, and I would call the unit rate now the constant of proportionality, because that is the unit rate. That's the number that goes up. So the constant of proportionality is the unit rate. Just on the side, I would like to just note that the graph for this first one is going to look like this because it goes through 0, 0. Okay, that one, that is linear. This one that is not linear, okay, is not going to go through 0. This is going to go through like this. It's going to be linear, but it's going to start at 2. Notice when x is 0, y is 2. And that is a lot of stuff, but I want to make sure that you understand, again, that a relationship can be linear, can be a straight line, but not be proportional. If it does not have a unit rate, if you are not multiplying the x by the same number every time to get the y, it is not proportional. And that number you are multiplying the x by to get the y is the constant of proportionality. Good job.